All right, so we made it to another Friday. We don't have a lot to do today. I want to go ahead and finally finish up with the trig equations, specifically those problems that don't result in a special right triangle. We'll go ahead and practice that again on Monday, but going into next week, okay, remember we have our next quiz on Tuesday. So it is going to have College Board questions on there. All right, so it's going to include those that we're talking about right now with special right triangles. So definitely be looking ahead to that. Every other day next week, we are looking at trigonometry and polar coordinates. Okay, and don't forget, next week, there's no morning tutorials. I do have duty in the dining hall. I'll be over there if you need to find me for whatever reason. But on Tuesday and Wednesday next week, I'll still have after-school tutorials. Just come on in, and I'll see what I can do to help you out. I think that's everything I have unless there's any questions. Okay, well, let's take a look at what we got here. So if we're going to solve equations that don't result in special right triangles or quadrantals, then we got to remember some information about the inverses. So first off, our notation is the -1. Remember, we have restrictions on each one. From each, you're always rotating from the positive x-axis. Remember, we called that standard position. There we go. So sine inverse can only be in quadrants 1 and 4, cosine inverse only in 1 and 2, and tangent inverse can only be in quadrants 1 and 4. Now, the difference between sine inverse and tangent inverse is that the y-axis, the boundary, can't be included because pi over 2 and negative pi over 2, tangent is undefined there. Okay, well, with these in mind, we're going to go ahead and do some examples. Now, the one thing I saw yesterday happening a lot through all the classes, remember, we've got restrictions and rules for the inverses, and then we have our rules when it comes to solving equations. So occasionally some people were kind of confusing the two. So let's see if I can help you out. All right, so we're going to go ahead and kind of skip around again. Let's go to number 6. Okay. So we have sine of theta equals 1/6. So we want to go ahead, we evaluate trig functions with an angle, and then the answer is going to be a ratio of two sides of a triangle that angle belongs to, a right triangle. So first thing, let's go ahead and solve for theta. So this is going to be theta equals sine inverse of 1/6. Now, while we're talking about inverses again, is there another way to write it in inverse without using the -1? Arc, yes. So sine inverse of 1/6, that is equivalent if I said arc sine of 1/6. Okay. So as we start going back into College Board problems again, we want to realize if it says arc, we are talking about the inverse. Okay, cool. So for this one, quadrant 1 or 4? Why 1? Because it's positive 1/6. Okay, so I'm going to go ahead and draw a triangle right here. Now remember, sine is going to give me y over r. So that means we have a height of 1, we have a hypotenuse of 6. What would be the other leg? Root 35, yes. Square root of 35. Anybody want me to run through Pythagorean theorem? No, we're good on that. Okay. Well, we can definitely tell this is not a special right triangle, but the angle here still exists. I'm still going to rotate from standard position to that hypotenuse. What we need to realize is that that angle is represented by this inverse here. So this is sine inverse of 1/6. Now, we want to know a couple things about this angle. First off, it's in quadrant 1, so that means it would definitely have to be acute. But more importantly than that, is it positive or negative? Is it positive? Okay. Now, as far as the inverses go, that's all I need. I know we're dealing with a positive acute angle. Now let's shift gears. Let's talk about the equation. Okay. Sine equals positive 1/6. All students take calculus. Where is sine positive? Okay, 1 and 2. And remember, we don't want to confuse the two. Sine inverse is only going to be in quadrants 1 or 4, but sine can be in any of the 4 quadrants. Okay, so 1 and 2, I'm going to go ahead and draw my 2 identical triangles here. In fact, it's the same lengths. We have a hypotenuse of 6, heights of 1, and then the base of a negative root 35. Root 35 on that one. Okay. Now, these two reference angles that we're looking for, again, it's this angle here. We don't know what the angle is, and that's okay. We don't have to know. So this is sine inverse of 1/6, and this angle is sine inverse of 1/6. So we've been talking about equations for over a week now. Once we've got the quadrants and the triangles set to go, we're going to start in standard position, and we rotate counterclockwise to each hypotenuse. So how far did I rotate this first time? Well, it's that angle we just identified. So that's my first answer. Theta is going to equal sine inverse of 1/6. Now, I want to start here, and I'm going to rotate over to the other hypotenuse. Okay, so we know we're in quadrant 2, but what would I use to write my expression? James, what do you think? Sir? Never mind. Mason? There you go. See, we didn't make it all the way to the negative x-axis, but if I go ahead and subtract this angle, whatever it may be from pi, that's going to give me this quadrant 2 majority angle that I'm looking for. Yes. So this would be pi minus sine inverse of 1/6. And that's what we want. Even if it's not a special right triangle, we still want to be able to find a solution to it. Okay. So is this making maybe a little more sense than it did yesterday? The first time you see it, it's a little weird. Okay, I'll admit that. Okay. Now, let's go back to number 4. So cosine of theta is equal to a negative 3/7. Okay, so first up, what would that be if I solved for theta? Okay, so theta is going to equal cosine inverse of a negative 3/7. Okay, now cosine inverse, oh, thank you. Cosine inverse can only be in quadrants 1 and 2. Okay, Enrique, what do you think about this one? Oh, 2. It's negative. Okay, so I'm going to go ahead and draw a triangle here. Okay, cosine has a ratio that's x over r, so I know the hypotenuse is 7. Okay, this base is a negative 3. Can anybody tell me the height? Oh, you're close. It is going to be 2 root, but not root 3. 2 root, no. Heard 6, 4, 10. 2 root 10. Okay. Now, do we need to go through Pythagorean on this one? Yes. Okay. So let's say this is a right here. So a squared plus b squared, a negative 3 squared, that's a negative 3 up there, is equal to c squared. Okay. Well, a negative 3 squared is 9 equals 7 squared. That's going to give me 49. When I subtract it, a squared is going to equal 40. Okay. And this is a radical that can be simplified. So the largest perfect square that evenly divides it is going to be 4. So the square root of 4 is 2 times the square root of 10. Okay. So good, 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 good. Definitely not I'll use green. Definitely not a special right triangle. Okay. But here's the thing about this. Okay. Cosine inverse of negative 3/7, unlike all the other problems, it's not this reference angle right here. Remember, you always have to start in standard position and you rotate over to the hypotenuse. So this is cosine inverse of a negative 3/7. Okay. Because hopefully you're going to recall, if cosine inverse is in quadrant 2, we're dealing with an obtuse angle. So we're dealing with an angle that's larger than 90 but less than 180. Okay. Now the thing about cosine inverse, it is only able to give you a positive angle no matter what. Okay. So questions on how I knew that? Okay. All right, well, we're done with the inverse side of it. We're going to take this information about a positive obtuse angle. Now, all students take calculus. Where is cosine negative? Okay, 3. So I'm going to draw two triangles right here. In fact, it's the same triangles that we have. Common leg is -3, hypotenuse of 7. This is a 2 root 10. This is a -2 root 10. Okay. Now remember, this cosine inverse angle that we're working with, whatever it may be, it's not these two reference angles here. It's this angle. Okay. Cosine inverse of -3/7. But remember, we have to rotate from standard position to the hypotenuse, so that means it's already my first answer. So theta is equal to cosine inverse of a -3/7. Okay, now take a few seconds, find me this other angle. We want to start in standard position, but rotate around to the other hypotenuse. Okay, so let's see if you can find that other solution for me. Oh, I forgot to put these in. Okay, is everybody about ready? Here's what we should be getting for our second answer. It is going to be 2 pi minus cosine inverse of a -3/7. Okay, does anybody need me to talk about why? Okay, so the thing here, what's going to help you is symmetry. Okay, remember, what do we know about these two triangles? They're exactly the same. So this angle here that we originally said was cosine inverse of -3/7, due to the symmetry, wouldn't this angle also be cosine inverse of a -3/7? Now, don't worry about the fact that we rotated clockwise. Cosine inverse is not negative. Okay? Remember, the negative just tells you the direction you're going to rotate. We know that this angle would be congruent to this one. So imagine if I took the whole revolution 2 pi and I subtracted off that obtuse angle, that would leave me the majority angle that I'm looking for. Okay. All right. Question. So how are we doing with these with no special triangles? Pretty good. Okay. All right. We've got one more problem, and then we are done. Number 5. So we've already talked through 5 of these together. Let's go ahead, have you try one on your own. Where is mine? Let me give you a couple of minutes to go ahead and run through this. If I can find my timer. Right in front. There it is. 45 seconds. Okay, here is what we should be getting. The first answer is pi plus tangent inverse of a negative 5/2. And then your second solution is going to be 2 pi plus tangent inverse of a negative 5/2. Okay, how many folks got that right? Okay, not a lot of hands going up. Okay, so let's talk about it. So I've already solved for theta. We got our tangent inverse here. 1 or 4? 4, because it's a negative. All right, so I'm going to go ahead and draw my triangle right here. All right, let's say this is y over x. So this would be negative 5. This would be 2. What's my hypotenuse? Okay, square root of 29. Anybody want me to run through Pythagorean? Okay, so definitely not a special right triangle, but I still have to rotate clockwise to get this angle that's represented by this. So this right here is tangent inverse of a negative 5/2. Well, being in quadrant 4, we know it's acute, but very, very important about this, positive or negative. What do we think? It is negative. Remember, we had to rotate clockwise to get to that hypotenuse. Okay. So knowing that, now let's go to the equation. So all students take calculus. Well, tangent is negative in quadrants 2 and 4. Almost misspoke there. So I'm going to draw the same two triangles. The height is going to be 5, basis of 2, and then we've got square root of 29 right there. Okay. Now, these two reference angles, they're represented by this angle that we have. Tangent inverse of a negative 5/2, and then tangent inverse of a negative 5/2. Now, if I were to go ahead and start in standard position, and I rotated that first hypotenuse, why wouldn't it be like a previous problem where it's just pi minus that angle? Remember, the angle itself is negative. What happens if you subtract a negative? It changes to plus. Okay, so if I actually want to subtract it, I'm going to keep it as plus, because if you add the negative, that's where you're subtracting. Okay. And then the same thing, if I were to rotate around to this other one here, this is a negative angle, and if I want to subtract it, I'm going to say 2 pi plus that negative. Okay, there we go. Question. So if you're still feeling a little hesitant about this, don't worry. We will look at this once more on Monday to kind of wrap things up. Then we'll get into polar coordinates. We'll take our quiz, and hopefully that week goes quick so that we can have a full 9 days vacation. Okay? So, question. All right. Well, let me go ahead and get this all ready. Let me shut it down, and we're going to be on SEL.